Alright guys, today we're going to talk about dimensional analysis from lesson 2-8, same one that our literal equations came from. Okay, so what is dimensional analysis? Well, dimensions are the labels, and analysis is to use them to help us figure out the problem. So, in other words, using the units of measure and that's what we call the dimensions. To set up a problem. Oops, wrong word. Up. And that's basically your analysis. How we analyze the situation. So, basically in a dimensional analysis problem, you're going to be given a situation. You're going to be told what you want the label to be in your answer, and then you're going to need some sort of conversion factor to get from one label to the next, okay? So we're going to call this have. That's what you're given. And we're going to set it up always as a multiplication problem. Times what you need. And those are going to be your conversion factors. And these are going to be written as fractions. Because what we're going to do as we set up is we're going to take the label we have, we're going to eliminate it by multiplying by a conversion factor that has a matching label at the bottom, leaving the label we want on top. Okay, so always written as fractions. And sometimes we have to do more than one of these. And this is going to equal what we want. Let's see, let's go down. Okay, so this is the label you were told you needed. Okay, so we're going to go through some examples so that you can understand this. Now, in 6th grade, we usually did one conversion, sometimes two, but in 8th grade, we get a little bit more intense, especially algebra. So we have a scenario, and it is a 10K run. Is 10 kilometers long. If 1 meter is equal to 1.094 yards, use dimensional analysis to find the length of the race in miles. Okay, so I know what I have. I've got 10 kilometers. Now I need to get somewhere from kilometers all the way to miles. Boy, okay. So let's see, how do we do this? Well, first off, I got to have fractions. So I'm going to go ahead and give him a denominator of 1 and then times. So let me think about what are all the things that I need. So I'm going to write down the one that we were given. We need 1 meter equals 1.094 yards. Okay. All right, so I have kilometers, but it tells me I need meters. So then I need that 1 kilometer is equal to 1,000 meters. Okay, that's great. Now I'm told I need miles, but they gave me yards. So I know that there are 3 feet equals 1 yard, because I know that 1 mile, oops, forgot the MI, is equal to 5,280 feet. Okay, so now what I need to do is figure out how to set up this problem. I know that my answer, my label of what I want is going to be miles. So what I know is that my last conversion is going to have the label I want on top. Now some of you might know that 1 mile is, I think it's 1,760 feet, or yards, I mean. 1 mile is 1,760 yards, but not a lot of people know that one. All right. Now I can either work from the front towards the back or the back towards the front, but I wanted to get this guy set up. So the label I want has to be on top of my fraction. All right. So if I continue backwards, let's see, I want to get rid of feet, so feet would go on top, so that would be 3 feet per 1 yard. Okay. I want to get rid of yards. Ooh, so I take the first one they gave us, and yards have, so I'm always putting the label I'm trying to get rid of on a diagonal to the label that I have. So I'm going to put the 1.094 yards over 1 meter. Okay, and then I need to convert the kilometers and the meters. Oops, I want to use purple on that one. So we're going to put the meters on top, 1,000 meters, over 1 kilometer. So look what happens. We've got kilometers, cancel with kilometers, meters, cancel with meters, yards, cancel with yards, feet, cancels with feet, and the only thing left is the miles. Now, I know what you're thinking. It's like, holy smokes, I'm supposed to do all that math. Well, the reality is, yeah, you could probably do a lot of it in your head, but I'd be okay if you used a calculator on this part. Though I'm going to tell you the problems on the test that you'll take, you don't need a calculator. Now, if I add up the digits of 5,280, it gives me 15, and I know 3 can go into itself once and into this guy. 3 goes into 5 once, which is 3 with 2 left over. 3 goes into 22 7 times, which is 21 with 1 left over. And 3 goes into 18 6 times evenly, and there's an extra 0. So I'm going to multiply 10 times 1,000 times 1.094. So that's a total of 4 digits, 4 zeros. I'm going to move my decimal point 2 to the right, because the number of zeros in that power of 10 tells you how many places to move it to the right. So if I go 1, and then 1, 2, 3, I'd have to fill up with a 0. So my interim answer is 10940 over 1760. So this is where I would be using a calculator. And calculators are going to give us kind of an estimated answer because often our answers will go on forever. So we have 15909, ding, ding, ding. And we're going to say that would round to approximately 6.2 miles. Okay, so that's dimensional analysis. All right, let's do a couple more examples. I'm going to do one where we need one conversion factor, two conversion factors, and then three conversion factors. Okay? So, next one. That was our first one. We'll do second one. So sometimes it'll just give us something simple, like convert 4.5 decades to years. So what I have is 4.5 decades. What I want is years. So what I need is a comparison between decades and years. And I know dec means 10, so it's 10 years is equal, or 10 years is equal to 1 decade. Oops. So notice what I had done with all those conversions before is I rewrote them as fractions. So I have two ways to write this one. Years over decades, or decade, 1 decade, over 10 years. So I'm going to have to figure out which one I'm going to need as I set up my problem. So I'm going to start with 4.5 decades. Now I need to create a fraction out of that, so I'm going to give them a denominator of 1. And we're going to put my label in that I want, which is years. So I want to get rid of decades and I want to get the years. So the years have to be on top, so I'm going to use that first fraction for this one. So 10 years. So notice the label here is the label I want. So 10 years, 1 decade. So decades and decades cancel out. So I just multiply 4.5 times 10. That's going to move the decimal point over 1 spot. And I'm going to get 45 years as my answer. Okay, let's try another one. Oops, sorry, 2 again. 3. So this one says convert 300 years to weeks. No, 300 weeks to years. Okay, so I'm going to think about what do I have. I have 300 weeks. And then what do I want? What label is my answer supposed to be in? And it says years. Okay. So, some of you might say, I already know how many weeks are in a year, but we're going to do it a slightly different way. We're going to use 2 conversion factors on this one. So, we're going to start by thinking how many, we go years, let's do weeks to days. So, I'm going to get 1 week equals 7 days. And then I need to get to years. And I'm going to say 1 year is equal to 365 days. So, 2 ways to write it. 1 week over 7 days, or 7 days over 1 week. So it kind of depends upon what labels I need and what labels I need to get rid of. Same thing on this guy. Or 365 days, 1 year. Okay, so let's start with what we have. And we have 300 weeks. So notice the labels are going to be part of the problem. Okay. And then remember we want to get to years. So I'm going from a small label to a big label. So my number is probably going down. So let's see. I'm going to need to use both of these. So I'm going to go ahead and put in 2 for multiplication. So I need to get rid of weeks. So that means I need weeks from the bottom. Okay, so we're going to do 7 days over 1 week. Now I need to get rid of days, and I need it to become years. So we want years to be on top because that's the label we want to end with. So we get 1 year over 365 days. So if I multiply, let's see, can 7 go into that? Let's see, 7, nope, that won't. I can divide out of 5, but it's easier to multiply. So if I multiplied straight across, I would get 2100 over 365. Now I would be using a calculator on this, and this would be approximately 5.8 years. Okay, I think I'm going to do the 4th one down here, and I may have to do some work along the side, so let's see what we come up with. So this last one, let's do 14 years, no, 714 years to minutes. So it's still a time one, but now we're going to use different conversions. So let's, what do we have? And we have 714 years. So that's a label we start with. What do we want? We need minutes. Okay, and then what do we need? Oh, we need a lot. Let me think. Minutes could go to hours, so I'm going to start with that. So 1 hour equals 60 minutes. Let's see, hours could go to days. So 1 day is 24 hours. Okay, and then I need to go from days to years. So 1 year is 365 days. Okay, so again, I can either put the hour on top and the minutes on the bottom, or the other way around, 60 minutes on top and 1 hour on the bottom. And then I could either do 1 day over 24 hours or 24 hours over 1 day. And then the last, I would have 1 year over 365 days, or 365 days over 1 year. Okay, let's see what we do. Let's start with 714 years. Turn it into a fraction. Now we're going to multiply by 3 conversions, 1, 2, 3, in order to get to my answer in minutes. Okay, so I can start from the back, and let's see, I want minutes to be on the top, so I'm going to have to use the 60 minutes over 1 hour for that. So that's going to go here. Okay, and then I'm going to kind of work myself backwards. So I want to get rid of the hours, so I have to find something with hours on top, which would be this guy. Oops, sorry, wrong color. Gotta get my need color. So hours on top, days on the bottom. Okay, then I need to get days on, get rid of the hours, or the years and the day. So years need to go on the bottom, days need to go on the top. So that would be this one. So I would have 365 days over 1 year. And so look what's happening. Years cancels with years, days with days, hours with hours, and I'm left with minutes, which is exactly what I want. Okay, so this one would be a ridiculously long problem to solve, so I'm going to go ahead and just let you know that it would be 375,000. I think I'm going to erase minutes and put it further away. Minutes. No, 375,278,400 minutes. And that's how you do it. All right, good luck with this, guys. We'll talk about it in class. Bye now.